still is good morning. If you didn't mark your t-shirt on the thingy by the door, make sure if you want one, make sure you put down what size of t-shirt you want on the thingy by the door. Okay?
How can I get a test because Mr. Rumpton put mine in the MRC and he's on lunch?
So on the two warm-up problems, if I plug in -2 into the function 2 to the x power, I would get 1/4. If I plug in -1, I would get 1/2. If I plug in 0, I'd get 1. If I plug in 1, I get 2. If I plug in 2, I get 4. So if I plot those points, -2, 1/4 is way down there. -1, 1/2 is a little up a little bit more. 0, 1 also happens to be my y-intercept. 1, 2, and 2, 4. So my graph would look like that. Is that a growth or a decay? Growth. Why a growth? As we increase the x, so as we go to the right on the graph, it's going up. Yep. The y values are increasing as the x values are increasing, so that's a growth. Okay. Do I have a horizontal asymptote, a line that it will never cross? Yeah? What is it? Y equals 0 is my horizontal asymptote. This function, I can never put a value of x into that function and have it be equal to 0. And I can never put a value of x into that function and have it be negative. Okay? Love it. Second warm-up problem. 2/3 to the x power. Now if I plug in -2, I would get 9/4. If I plug in -1, I'd get 3/2. If I plug in 0, I'd get 1. If I plug in 1, I'd get 2/3. And if I plug in 2, I'd get 4/9. So 1 and 2. Oh, that was a little farther out. 1 and 2, 1 and 2, 1 and 2 and 3 and 4. So here now, if I'm at -2, that's up here. If I'm at -1, that's there. If I'm there, and then I'm there, and then I'm there, and then, so this one looks like that. Growth or decay? Decay. Why a decay? Why is it decaying? Anyway.
Because the base is less than 1.
Okay, that's another, because the base is less than 1, so that's going to signify an exponential decay. Okay, I like that. As x is increasing, y is decreasing. Or as we're going to the right, our values are getting smaller. Yep. Okay. Y-intercept is also at 0, 1. We found that in our t-chart. And our horizontal asymptote still is y equals 0. Agree with all of that? Love it. Okay? So, some thoughts from Algebra 2 last year. We were able to identify exponential growth or decay based upon the value of b. Let me see if I can make that a little bit bigger. There we go. There we go. Okay. If what values of b make it a growth function? If b is greater than what? 0? Do we agree with greater than 0 for a growth function? Terry, you're shaking your head no. Would you like to tweak that? Greater than 1? What about equal to 1? Could I be greater than or equal to 1 and still be a growth function? $50-50 shot. No, can't be. Because if I'm equal to 1, then I'm horizontal. I'm not growing or decaying. I'm staying the same. Okay, so that's a no. So b, if b is greater than 1, I'm a growth. Okay? What about decay? Less than 1? Is that the only classification? Greater than 0, because b has to be positive. Yep. So it'd have to be between 0 and 1. When we graph exponential functions, we're really only going to graph 2 key points. Okay? And we're going to make it easy on us, because we're going to be able to tell if our exponential functions are growth or decays. I mean, right now, we're dealing with exponential functions with training wheels. Okay? Ideally, starting tomorrow and going forward, we're going to want to graph, or our exponential functions are going to be base E. And then we have different rules that apply. Okay? But right now, we're going with, we got to learn about exponential, or relearn about exponential functions before we can get to that. Okay? So we want 2 key points. If you look back to the top in those warm-ups, which were the 2 easiest ones to find in your T-charts?
X equals 0.
And? When x equals 1, yep. So when the exponent, because in those 2 cases we only had exponents of x, so it was when the exponent equaled 0 or the exponent equaled 1. That made it easier on us. So easy, in fact, you probably didn't even have to use a calculator to calculate those 2 values. Okay? Those are the ones that we want when we're sketching, because we're going to know if it's going to grow or if it's going to decay based upon those 2 points and the b value that we know of. Okay? So, if my exponential function is of the form f of x equals a times b to the x, what's the y-intercept? Or what point is the y-intercept? That function, where's the y-intercept? What do you got?
0, 1.
0, comma 1? Do you agree with 0, comma 1? Good, because I don't either. What do you got? Point in point form? Zero comma a? Do we agree with 0, comma a? Yeah? Maybe? Okay. Well, let me ask the same question in a totally different way. How do I find the y-intercept? On any function. How do I find the y-intercept? Plug in 0 for x. Okay? So the y-intercept is going to be the point 0, comma, something. So I plug in 0 for x. in that function. B to the x power, so that becomes b to the 0 power. What's anything to the 0 power? 1 times a. So the y-intercept is at the point 0, comma, a. And for all of those functions, the horizontal asymptote is the line y equals 0. Now, that's not the only kind of function, exponential functions that we have. Because if my function was equal to a times b to the x minus c power, then plus d, okay, now things get a little shifted because of different aspects of that, or of exponential functions. So first off, this a value right here stretches my function vertically. It's either going to make it go way up and grow really, really, really fast, or it's going to make it grow really, really, really slow, or decay really fast, or decay really slow. Okay? Depends on how or what the value of it is. Okay? It's also going to have an effect on our y-intercept. C in here is going to shift the entire function horizontally. When we were dealing with conics, the unit we just got done with yesterday, we talked about things when they're inside parentheses, you have to think oppositely for. In exponents, that's the case too. You have to think oppositely as to which way it's shifting. So if it's plus C, that's actually a left shift. If it's minus C, that's a right shift. And D shifts things vertically. Which also affects your asymptote. But again, the easiest points to find are going to be when your exponent is equal to 0 and when your exponent is equal to 1. Okay? So, let's put it to the test down here at the bottom. You're going to graph them both on that same graph. So if you have two colors, this would be a two-color type of thing because then you can distinguish between the two. If you don't, you're going to have to make sure that you know which one is which. Okay? So, f of x equals 4 times 1/2 to the x power. Okay? So, the easiest points to graph are when the exponent is equal to 0 and when the exponent is equal to 1. So in this particular case, that would be at 0, at x equals 0, and x equals 1. Agree? Okay, love it. Plugging in 0. What do I get out? 4. Plugging in 1. What do I get out? 2. Growth or a decay? What? Okay, so we can do this one of two ways. As my x value increased here on those two, my y value decreased, so therefore it's a decay. Another reason. B is less than 1 but bigger than 0. Yep, so therefore it's a decay. Love it. Have I found my y-intercept? Yes? What is it? 0, 4. Love it. Did I have something out here after my exponented term that would shift my graph vertically and therefore affect my horizontal asymptote? No. So that's going to stay at y equals 0. Okay. So it's a decay. I went through there, and I went through there. That tells me then that it's going to look something, so I got to be able to see shadows and all. Look something like that. Would you agree? Okay. Second one, I'll put in blue this time. Okay. Need my exponent to be 0. So what values am I going to put in for that? I want my exponent to be 0. -3, and if I want my exponent to be 1, I would put in -2. Now, the unfortunate thing is neither one of those is going to give me a y-intercept, correct? So what do I have to put in to find my y-intercept? 0. Yep. So I actually, on this one, I got to find an extra 1. So -3 in the exponent plus 3 gets me 0. 1/2 to the 0 power is 1 times 4 is 4. -2 plus 3 is 1. 1/2 to the first power is 1/2 times 4 is 2. 0, if I plug in 0, 0 plus 3 is 3. 1/2 to the third power. Yeah. 1/8 times 4. One-eighth times 4. Half. Okay. So my y-intercept is at 0, 1/2. my horizontal asymptote. What's my horizontal asymptote? Y equals 0. Is it a growth or is it a decay? Still a decay. So as you can see, we started with black, we went to blue, and it got shifted over to the left 3. Okay. Oops. That one. There we go. Okay. So, now, down at the bottom of the second page, okay, so that we're picking up on number 7. Okay. F of x equals 4 to the x power, then plus 1. Automatically, what do I notice about this one that's different than the last two that we just grabbed? It's got the plus 1. It's got this extra purple part over here. Okay? So what does that do?
Up and down.
Shifts the whole graph up and down. Or up or down, which way?
In this case, up.
This case it would be up. Okay, so it shifted up 1, right? So what all gets shifted up 1? The asymptote and the entire graph, right? The y-intercept and all that fun stuff. Okay? So my my horizontal asymptote here is what now? Y equals 1. What would it be in number 8? Y equals negative 2. And in number 9? What? 2 is a number. Y equals 2 is a line. Okay? There's a difference. Okay? There's a difference between saying 2 and meaning y equals 2. Okay? 2 is a number, 2 away from 0 on the number line. Y equals 2 is a horizontal line, 2 above the x-axis. Big difference. Okay? You may not think that, but there is mathematically, there's a big difference. Just the same as, I don't know if you've been hearing me pick up on you saying y-intercepts. 0, 1, okay, is the number on top of the General Lee and the Dukes of Hazzard. Okay? 0, 1 is a point in space, 1 above the origin. Okay? Right? They're different. Okay? If we go across the hallway, I don't go into the German room and start speaking French and expect to get an A in their class. Okay? Know what I mean? All right? So, we'll go blue. What is the y-intercept here on this one? Shout it out when you think you know it. What do we got? 0, 2. Do we agree with 0, 2? Yeah, okay. 0, 4 to the 0 power is 1, plus 1 is 2. 0, 2 is my y-intercept. Is this a growth or is this a decay? It's a growth, so the next point to the right should be above that blue point. If I plug in 1 in my brain, 4 to the first power is, plus 1 is 5. So then we go through the point 1, 5. And there is my growth. Got a horizontal asymptote on this one. We found already. We said it was at -2. Green on this one. Okay. Y-intercept. Y-intercept for this one. Zero comma -1. Is it a growth or is it a decay problem? The decay, so that means it's going to go down, right? So instead of plugging in +1 for this one, what would be a better choice to plug in? Since it's a decay. -1. Okay, so if I plug in -1, 1/2 to the -1 power is 2, minus 2 is 0. Okay, so this one actually goes to the point -1, comma 0, and would look like that. Make it easy on yourself. If we would have plugged in 1 there, we would have had 1/2 minus 2, and then we would have to be dealing with fractions. Okay? -1.5. And I know how much you love fractions. Okay? Try graphing number 9 on your own. I get a y-intercept on this one of 0, comma 34. Agree? So I plug in 0. 0 minus 1 is -1. 1/4 to the -1 power is 4. Times 8 is 32. Plus 2 is 34. So I'm way up here. This to me is a decay. So if I go with +1 there, I get +1 minus 1 is 0. 1/4 to the 0 power is 1. Times 8 is 8. Plus 2 is 10. So we're in about there. So it decays rather rapidly. On all of these, the graphs, the horizontal asymptote is at the line y equals d for that one down there at the bottom. Now, what we are asking you to do is we are asking you to do the 6 graphs at the top of the page before you come to class tomorrow. Okay? 6 graphs top of the page before you get into class tomorrow. Okay?